Alright guys, Modarra Monday. Today we're going to be working on these tiny little screws here. We're going to be remaking them, adjusting the program, dialing this in, and then I have a question about a fixture that I want your guys' feedback. So we're going to play that clip first because I want as many people to see that as possible. So cue the clip. Okay, the first part of this video I want to go over a fixture idea so I can make sure I get your guys' attention, because with YouTube people click off and I want to get as many people to see this part of the video as possible. So the problem that we're gonna have is I wanna make as many screws as we possibly can. And again, these are very, very tiny screws. We're making it out of 1/8 inch stainless steel stock round bar. And what I'm thinking is we want to take advantage of the same concept. We're calling it the salami method, which is where we're taking a long strip of material and we're going to, if this is our material, we're going to machine a part off the top, we're going to tab it off, break that off, and we're just going to advance the stock and keep doing that. That's going to allow us to not have to deal with bandsawing, individual little pieces of material, etc., etc. So this is a crazy idea I had. The thought process here is I want to hold as many pieces of stock as possible. I want them to be at least 5 inches long, if not longer, and yeah, I want to maximize runtime. So here we have our pallet, so we could pallet change this, and I strategically placed these holes. Now, this would be our stock, this orange round bar here, and this is sticking up just enough to machine a screw, and then what we would have here on the sides, I'm going to draw this really crudely, is we'd have a bunch of set screws, so we could do our trick where we, this is a through hole, and we have a set screw that pushes this up and locks that one in. We have one that goes all the way back there, etc., etc. So we're able to hold 94 pieces of material here. So we could make 94 screws in one cycle. We could make 2 of these pallets, and we could be unloading one while the other one's running. And that is the thought process here. I'm very curious to see what you guys think. The reason I'm doing kind of this staggered approach is because we can get even more parts. Obviously, if I eliminated what my fingers are covering, we would just have this perimeter, which I think was like 50 some parts, but allowing there to be even more, obviously, longer run times. So let me edit this sketch and I can show you kind of the layout here. So this is our 1/4 inch slitting saw, or not slitting saw, key seat cutter. And so I come in here and you can see I have it designed where there's clearance on all these edges. There's clearance here, 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 boom, boom, boom. So there's clearance for all the tools to come in. The question is, do we think this fixture is the best approach to make these parts? It is pretty wild looking, I'm not gonna lie. But again, if we want to, like, our criteria is we want to use sticks of material. We obviously only have our haas 5-axis. We're not using the 5-axis in this at all. And we want to hold as many parts as we can. I don't know of any other way to do this simply. I think this is, as weird as this is going to look, I feel like this is the most simple way to hold these pieces of material. So I'm very curious what you guys think, if you guys understand this concept. And the reason we can't keep going, even more rows is because obviously we can't get a set screw back there. You could maybe do like a terrace stair step approach and get even more parts, but for right now, I'd be so thrilled to be able to make 94 screws in one cycle. So let me know what you guys think. That's really the most important part of this video, is I'm very curious on this fixture design. I'm not going to start making this fixture until I start seeing some comments and feedback, because this will be probably next week's video, depending on what you guys think. So again, curious your guys' thoughts. Let's go ahead and talk about these screws a little bit more, and then we're going to go make some. Okay, let's go over a couple things. So last week we worked on our screwdriver. The week before we worked on the screws, and we made the screws fully threaded, as you can see here. Now, the reason for this was because the original screws had a lot of slop and play into them, and this was one of the early prototype screws I made. Take this bad boy out. So you can see the difference. One is fully threaded and one is only partially threaded. We're going back to the partially threaded design, and that's because I don't know why I went with the fully threaded design other than to pick up the slop that I was creating, because the difference in diameters, and I have this all written out here, is the diameter of this 440, the external threads is roughly 110 thou, and the diameter of this small shaft here is 85 thou. So the difference between those two, when we do all the math, so if we look up here, we have the link hole size, which is this hole here, that is being drilled as a 114 drill. The CAD design is 115, so I'm kind of assuming the drill is going to be oversized, and it is. So I'm drilling it to 114. I measured some of these. They can go all the way up to 118. So that's my high end, is 118 on this actual hole size. Then the actual diameter of this threaded bit, if we're using the old screw, is around 110, could be as low as 108. So that gives us, if we take our highest and our lowest, that gives us 10 thou of play. So I like that. And if we actually go back even further, these are the original set screws, and these are actually what's holding together my bracelet right now, are these hex 440 set screws, and those again have a major diameter of 110 thou to 108 thou, in that range. So that's what's currently being worn on my bracelet right now, and it's the perfect amount of play. We actually have, here are some of the links that were electroplated, or not electroplated, electropolished, and the play that I'm talking about is, if we set this down, it's the, front to back play here, because that's actually what's being affected by the diameter of the screw there. And this a little bit could be, that's more of the actual link, like tang, if you will. But so we're really looking for is this. Now, so again, to rehash, these are 440 set screws. We are using the threaded section as a pin, and I understand that is not a good idea. You guys pointed that out, and I totally agree with that. So we're going to go back to my original idea, which was these screws here, which is just threads enough to go through this first section, and then the rest is just a pin. So if we do that, if I show you and I actually screw this in, hopefully you guys can start to see. Let's do this. See, this is an old screw, so my screwdriver doesn't fit as well because it's way sloppier of a fit. Okay, so now you can see that it is pretty much exclusively just a shaft in there. There's almost, you see like the lead in of the thread, but there's actually no thread that's exposed. So now the question is, okay, if that's going to be our size, what is the diameter of this pin? Well, it's about 85 thou, and that changes things. So if we move over here, we have, if I go to a 85 thou screw, so here's my screw drawn out, here's the threads, here's the shaft section. This needs to go into the hole, and the hole, to match the same 10 thou play or slop, we need this hole to be about 95 thou instead of 114 thou. Luckily, all we should have to do is change the drill out of the tool holder, and we could, I could adjust my speeds and feeds, I guess. It's such a small difference though. But my whole point is, we actually don't have to change the program. We literally just have to swap out a drill, and we are going to be making this hole size here smaller. That's all that's going to be changing here. Now, what I actually really like about this, thinking about it, is these wall thicknesses is about 15 thou. This is going to beef up the link a little bit, and I'm totally down for that, because I'd like to in the future maybe send these out to get like load tested. I know that's going to be the weak spot. You can see how thin that is, but imagine we're going to shrink that hole size by, we're going down, what is that, 20 thou? 5, yeah, something like that, 23 thou. So we're going to see at least 10 thou thickness change, maybe 10, 11, 12, because you take it, you split it. So that's going to double our wall thickness here. and make it much stronger. Not that these were ever, you know, a problem, but it will be nice to know we are beefing up probably the quote-unquote weakest part of the link design by doing this. So what I'm going to do is I'm going to show you guys a fixture idea, and actually I might already show you that. So what we're going to do next is we're going to go down to the machine and we're going to make some new screws, new old screws. We're going to be making some of these, but with the 64th slot in the top, and then we're going to make sure the lengths are good. So that will be our final screw, and then we could start actually swapping some of these out. Okay, we've been here before. I'm probing in a piece of 1/8 inch steel just in a collet block. We're just running one program just for one screw here. Again, we're just proving out our program, proving out our part, and then we got to figure out our fixture design. But I want to make a few of these the old slow way with it, which is just one at a time in a collet block. So let's go ahead and do that. Well, we just made a screw and it looks good, except there's no T-slot. I think we broke our tool, so I got to pull that tool up and take a look and see what's going on. Okay, we successfully made a smaller screw. If you can see, really loving the smaller T-slot look on the stainless. And yeah, I mean, it's dialed in. The only thing that we need to figure out is what to do for our op2. So for the op2 of the screw, we have this little pit, if you will, and we need that to be flat because that's what's actually pushing against the flat bottom bore of the link. And so we don't only need it to be flat for that reason, but we also want to engrave an M on the bottom of the screw. I've talked about this before. I want all the parts to be marked somehow so you know it's a Modarra part. So the thought was maybe make a little, you know, a little plate of some kind or something that we can thread these in, and then we could face off the whole back side of them and then engrave that on the haas. I don't know if we drill and tap a hole that's a blind hole, blind enough. I'm just trying to think, how could you control the stick out of this screw by doing that? Might have to think about that a little bit more, but I'm very curious if you guys have some thoughts on op2 of the screw, because yeah, it's great that we could potentially make, like I showed that fixture, you know, 94 screws at once, but we still have to do the op2, and I want that to be pretty quick. It would be nice if we could do it on the haas, because we could again make a big fixture and do a bunch of them at once, versus I was going to like put this in the little lathe I have, just a manual lathe, face it, and then engrave it on the laser. But if we could do it all on the CNC, that would be pretty sweet. So I'm curious what you guys think for an op2 for the actual screw would be. So let me know what you guys have to think in the comments, what you guys have to say in the comments down below. All right, the haas is running right now. We're gonna make a few of these screws just while we wait here. Get this going again. So, all right, the haas is running behind me. We're making another screw. Again, one at a time. The cycle time's around 5 minutes. I think we could get that down a lot. Now, hopefully you can still hear me now that the air compressor's on, but we've got a lot that we can do to this screw. I really need your guys' feedback on the fixture and then the op2 of the screw. I'm very curious if you guys agree with the fixture design and the op2 approach. So I kind of don't want to spend too much more time on this until I get the fixture dialed in, because making them one at a time is really painful. So I'm gonna run a few more while I'm like cleaning up my shop a little bit for the next half hour or so. I'll make a handful of them, but we still need to figure out how to do the op2 before I can put them on my bracelet, because right now that little pip makes the screw actually stick out proud of the link just by like 5 or 10 thou. So looks wise it's not there, and I don't want that on my wrist. I want these to be dialed in first. So curious what you guys have to say. I hope you guys enjoyed this video. I'm trying to put as much as I can into these videos. Again, if you guys don't know, I only work on this on Sundays. So I literally wake up, I start programming, I start my day with Fusion while I eat breakfast, and then I come down here and I start working on stuff as much as I can before lunch. I eat my lunch, I come back out here, I work, and then I do as much as I can, and then I gotta edit the video and post it. So I'm doing all of this on Sunday. Like I've talked about before, I am constantly thinking about these things throughout the week though, if I have a spare moment to think about something, or I kind of want to change gears and think about things. So that fixture that I showed in the beginning of the video, I've been thinking about that for weeks at this point. I feel like that's the only way to make these parts in mass with my current setup. So the beauty of that fixture though is we can also use that to make our little screwdrivers. So it will be a multi-use fixture, which is good. The other thing, well, I'm getting ahead of myself. So yeah, I want to dial in the screws. We've got the links, we'll get the screws, and then we have to dial in the actual clasp here, which is the part here that says with the M on it. It's actually a really good thumbnail right there. So that's what we're going to be working on in that order. Screws, and then I know I'm kind of ranting right now, but I just want to talk out loud, is get the screws dialed in, and then we'll go to clasps, and then it's going to be kind of this awkward stage where we're going to have to make a new link fixture, and then the screw fixture, the op2 screw fixture, and then op2 link soft jaws or whatever that looks like, and then the clasp is going to be a pretty simple fixture, but we also have to make that. So we're kind of proving out all the processes, and then we're going to remake all these fixtures from scratch. We're going to make them nice with what we've learned this far, and then we can go to production of the Founder series. So that's the goal. I'm doing as best I can. I'm spending as much time as I can with this, but I don't really know what else to do today because I want to see what you guys have to say about these. So I'm going to make a handful of links, and we'll be able to use those for op2 testing. So that's where we're at. All right, guys, thank you so much. Follow the Instagram, and I will see you guys next Monday.